You can see my screen, isn't it?
Yes, doctor, we can see.
Okay, thanks, Prasanka. Right. IT516 system analysis and design. We are discussing system analysis phase. Last time we discussed object modeling. So today we are going to discuss about the development strategies. Basically, we are going to look at what are the options available under the development strategy. Right. Okay. So having said that, let me start today's session. Now, once you have the, design phase, so you have to think about what are the development strategies you have. That means once you have decided on what kind of information systems you are going to have, we need to design like what will be the development strategy, right? Now, for example, if you look at like what happens few years back, sometimes if you look at what companies did in software development, they have developed software themselves, right? Or the other option would be they could purchase it, from as a software package if it is a common one, or else they could hire consultants to do the work, or maybe you can outsource or hire outside resources to perform the work. Now if you look at what is happening nowadays, things have changed, right? So now what has happened, most of the time we have application service providers which we can actually directly use them, and also like web hosted software options, like means early days we have everything in our places in organizations, starting from hardware, software, application software, everything will be in the premises, which means the same place. And now things have moved to the outside, like we call sometimes the cloud, meaning you don't have anything, right? What you might have is a browser and internet connection, but then you have everything, right? So things have changed over the years, how things have actually developed, right? And now people, if you look at, different firms, they offer a wide variety of software solution. So selecting which one is the best is very, very important. And this is exactly what we are going to discuss. So in this topic. So under the topic, we are going to discuss what do you mean by the software, especially software as a service, and how things were in the web version 2 and cloud computing. We can discuss what will be the web 3.0 and so on. And then software acquisition alternatives, what means the traditional ones, the web-based software development strategies, outsourcing options, and what are the advantages and disadvantages of in-house development versus like you take it from outside. And then we will conclude our discussion by looking at financial analysis tools. So we will do cost estimation of different alternatives, right? Now if you look at what has happened over the internet, now you can see like most of the time things were evolved as a software as a service, right? For example, there are three things that we will discuss under the cloud computing: infrastructure as a service, then we have platform as a service, and then the software as a service. Since we discuss about the software implementation, we can focus on that. Now in traditional model, software vendors, they develop sell application software to customer, right? And basically we can purchase some license which the users can use under the whatever the terms and under the license agreement. And a software as a service model is a slightly different. It will be hosted as a service provided customers through the internet. And the advantage the customer will get is they don't have to maintain software or operate in the software or supporting. So everything will be taken care of the service providers. Right. Now, so here is what it looked like, the software you have, and also, the different, solutions or different way we can think about the software we will have. So one is on premise, which means everything we have or managed by the organization, meaning like starting from the hardware, that means server, storage, virtualization, networking, right, and so on, and then an operating system, middleware, runtime, application, everything is done, managed by the organization. Right. I would like to ask from the audience, like how many of you in your organization you work, right? You hold everything in your place as a software. Can some of you volunteer and tell me how exactly in your organization you manage software? You hold everything in your place? Do you have your own servers, software, as well as application software, and you are managing, meaning like you have IT department which manage everything? Yes. Now, let me give you like what happens in the Uniswap Peradenia's perspective. Now, in Uniswap Peradenia, we have a couple of software solutions. Some, yes, we have some software in cloud, meaning like, for example, email services. Now we have moved from our services to Google, Gmail, for example. But then again, student results and also like other software, we have our own infrastructure. That means we manage everything. I think I can say it's on premise. We have a network services unit. We have a NCSU guy. I didn't remember the name. Yeah, what are you here today?
Yes, sir. Yes, Tarindu, sir.
Okay, yeah. Why don't you like, instead of telling me, why don't you talk about like what software we handle in our system?
So we are using that VMware to provide virtual servers,
Okay.
VMware solution, and latest presently we purchased Sky solution. It also we have servers and distribute client to the updates and thing. There are a lot of services.
Exactly. Now, for example, some of the application, the website and everything, we have web servers and things were managing. It's, we can say on premises, because network services units handles the hardware part, and you are providing all like fault, that help will given by the network services unit. So that means we have a specialized IT team for that. So Tarindu and the team will help you on that, but web updates will be done by different faculties, and for university we have a separate web development team, I suppose. And then there are like some payroll systems handling accounting department, that also comes under you, or they have their own servers? Tarindu?
They have their own servers. We have separate that VLAN from our internet VLAN, and they are managing their networks.
Okay, so I think that
Their
is the
servers.
security aspect. So
Yes.
that actually they have their own, right? This is just to give you like how we manage. And as a faculty of engineering, we have our own setup for handling student registration, results, and so on. How about in PJA? Do you have any idea, Tarindu, like how PJS handles this student visas? Are they have their own, software in a separate place?
So they are managing their own networks. They are
Okay.
not depending on our networks. I think they purchased the domain from the SLD, and they have some public IPs, and they manage their own servers.
Okay, yeah, I understand. So you can see like how things will operate in our, organization. So how about Pradeepa? Pradeepa, where are you working? Or is it Pradeepa? Bokalavella?
Yes, sir.
Yeah, Pradeepa, yes. I just want to know, like, where are you working?
Working in Zonal Education Office.
Sorry?
Can be. Zonal Education Office
Okay,
can be.
Sonu. So I hope you are using different software to manage the activities in zonal education. Is it? Do you have any idea?
Yeah, but we don't use that much softwares. Actually, we use softwares prepared by ourselves using most of the Access and Excel likewise. We don't have, we use payroll system and financial based softwares. For other transfer, we use Excel based our own softwares.
Okay, thanks Pradeep for sharing, the software, handle. I think most of the time you have your own setup. How about Udang?
Yes, sir. I work in Rajarata University.
Okay.
Yeah, there are we are using all software. A lot of time we are using all software, like Pradeepa says before.
That means like you have your own developers, like you have software engineers or software managers who develop the software and take
Yeah,
advantage of
yes, sir.
And
Like
do you have your own setup, servers and everything is in on premises?
Yeah, yes, sir.
So no software you have in a cloud base, like which means like independent of your organization. Have you
Yes, there are. I think there are use cloud-based software like. I don't know much about this. I think
Okay.
there. Yeah.
No, that's okay. I mean, like it's perfectly all right.
Okay.
How about Hasanti?
Yeah.
So I'm working at Department of Agriculture.
Okay.
India, we are managing our own softwares like that, access based and other maintaining websites like that.
I understand. I understand. Okay, thanks for sharing. I think majority of our case, like when it comes to Sri Lankan context, I think is still we are on premise. We were not sure about, like sometimes we are concerned about the security and all, and we don't want to depend on any other. So we are spending a lot of money on infrastructure as well as middleware plus application. But then again, I also notice in many of the times there are a lot of failures because like although we have expertise, sometimes it might sometimes take some time to manage. I think Taridu can correct me sometimes when there are failures in our own network. So sometimes we missed some of the software to use for weeks sometimes, isn't it? So the trend is, I think, moving towards the cloud, meaning like what organization manager will be minimal, right? For example, infrastructure as a service modeling the cloud computing, we will have hardware managed by the vendor, and what is managed is only middleware part plus the application and data. And when it comes to platform and services, especially if you're concerned about the security, you can have application and data and all the others you can put into the cloud. But now the trend is like software as a service, but that means everything will be on the cloud. And sometimes the payment structure, the payment module, sometimes you pay for what you have actually used, right? So remember how much cost we spend on, hardware. Maybe every 3 years or so, we have to modify this, and sometimes financial difficulties are there for us. So I don't know how practical sometimes, everything handling on premise. So, that is something that we need to think about. Right. And then then there are a lot of categories if you look at, and some of you have already discussed now. For example, right now we are using Zoom, and it's basically service provided in the cloud. And we can have local service as well. For example, Zoom, we are having our own setup and the university, and through that we can communicate each other. So that is, to reduce the cost that we have to, bear for, these software. Now, similarly, there are like Google Workspace, a lot of collaborative tools are there, like, for example, Microsoft Office. I don't think now we have to purchase Office packages, because if you have the internet connection, if you have, Google Workspace, you have everything you need, for free. And at the end of the day, you can convert into whatever the format you want, right? So you can see there are a lot of, services provide, develop for various places: individual productivity, team productivity, communication, workflows, websites, e-commerce solution, customer relation management, admin, supply chain, procurement, HR, finance, everything is there. So only thing is, like, we have to get familiar with these services, and maybe sometimes you need to have some customization to adapt into your organization. But you can see the trend towards, in this direction. Right. And then the next thing that I would like to discuss is, like, when you talk about the software as a service, it's the idea behind like centralized computing, your entire business organization, and also the employees, their tools online, and usually we call rented products, right? You pay for some fee, like maybe yearly, right, based on the organization. And that sometimes the cost that you have to spend for this one could be reduced, right, depend on number of employees you have, right? So when you make bulk purchases, the price of a license or the product will be quite low, and all the processing work and files are done on the internet. And what you need is, you need what we can call internet and a web browser, like Google Apps, for example. So nothing is saved in our machine. Yes, we can have like offline synchronization in case something goes wrong, or if you want to work at offline. Otherwise, it could be in online. You don't need a hard disk space nowadays, right? Everything could be online. So that is one of the advantages you might get in software as a service architecture. Right. Let's move on to traditional, web-based traditional, development versus looking at web-based development. Right. In traditional systems, we will have various hardware and software environments, because we have some legacy systems, and with the constraint in company network, desktop computing capability, because you are limited on whatever the equipments you have, right? And we can use internet and the resources for the enhancement. Now, if you look at internet-based systems or web, if you take a platform, then you can use it as a communication channel. So many companies nowadays use web-based systems to handle enterprise-wide application. So sometimes we say ERP solutions, from A to Z, you can manage everything within this. So if you look at the web-based systems, the advantage you might get is it is easily scalable. Like if your organization is growing at a rapid rate, so you can adapt very easily if you have a web-based system. And the dependency on hardware and software also very minimal, right? And then you can, more on towards, you can more work towards the outsourcing operation and the supporting software application, right? So which means compared to traditional development, if you focus on the web-based development, there will be a greater benefits with risk, of course, compared to traditional environment. And nowadays, since we are using different devices, that when you have developed a web-based system, you can use it on desktop, tablet, as well as your mobile, right? So that is also there. Right. How many of your applications run on different platform, like your software that you use in organization, are they capable of viewing in different platforms? And that means desktop, mobile, are they web-based, or are they it's only the desktop versions you have? Right. Kanishka, where are you working?
Agriculture department, sir.
Are you also in the agriculture?
Yeah.
Same with Hasanti?
Yes, sir.
Okay. So in your software in the agriculture department, do you have, are they web-based software, or can we view it in different devices like mobile and all?
We don't have any software in web-based. We are doing web development, so we don't have any softwares.
Okay, thanks. How about Anjana? Where are you working, Anjana?
Hello, doctor.
Yeah.
Working at school, they are using the web-based application mostly. So it is easy for us because of every process we can use it.
Okay, thanks.
Then
You are Anjana, right?
Anjana.
Okay.
Then
Sorry.
when I were in before office, they used the web application and the mobile application also. They have a separate servers also. It's paid for Google one also. I can remember when I worked there, we used the username password, but we can't access that only at office only because of the security services. We used that one also, doctor.
Okay. So that means like all the kids, like the student details are recorded in digitally.
Yeah, mostly digital wise.
Oh.
Better to ignore the paper based.
Okay, I understand. Okay, Prasad. Prasad Jaisingh.
So I'm also working at Department of Agriculture.
Oh, okay. So how many of you are working at the Department of Agriculture?
Actually, we have 4 here.
Okay, you have 4. Who's missing here then? I think Asanti met a couple of times, Kanishka, then Prasad, then who's the other person?
Anuka.
Anupama.
Anuka Ratnaik.
Anuka.
Yes. Ratnaik.
Ratnaik MAAH, is it?
Yes. Yes, sir.
Okay. Hello, Anuka. Okay, right. Okay then, right. So you will have the same setup. Okay, let's back to the slide. So you can see the changes in the web development. If you look at in a traditional system development environment, the design is influenced based on the compatibility issues, because you have to meet whatever the existing hardware and software platform as well as legacy software. I remember in sometime back even in Europe, they say most of their financial systems were developed in the legacy programming language like COBOL, right? They are still depend on it. So even when you develop a new versions, they have difficulty because still they look for the developers who knows these legacy systems, because they have done a lot in that development environment. It's not like we are developing something new. If you are thinking of using existing software, right, then you have to think about all these constraints you have. And systems are designed to run on local or wide area company networks, not on the internet. Most of the time it's restricted to the company wide network. And then what it uses the internet and all as resources, but web-based features, they are just like some of the elements, not as the core elements of the design. And there are a couple of paths are there in traditional development. You can have in-house development. I think many of you, told me that in your organization you have, developers. And the second one is you can purchase software packages with, modifications, or right, you can use somebody from the outside to do the work. But the problem with the traditional software, as I told you, if you want to expand the capability of the software, right? If the organization growing, so meeting the growing demand might be a problem because you are dependent on existing hardware, right? And then many of the applications you need like substantial desktop computing power and resources for the software you have. And security issues is less complex compared to web-based, because everything in yours. I think that is one of the reasons why we tend to have our own servers and our own software, rather than we depend on the internet. Right. And if you look at web-based environment, that is the recent or now what is happening nowadays in most of the time, the systems are developed entirely based on internet domain. They use the frames of different frameworks. There are .NET, WebSphere, or nowadays the recent one, most of the applications, they can use things like Google App Engine or AWS Lambda and so on. So you can see that you base on some kind of a framework. And these development, they take the web as a platform, right? And the opportunity you get is you can easily scalable, right? You can increase depending on the demand, you can add nodes. So it's easy with the web-based development. And large firms organization, they tend to deploy web systems as enterprise software solutions. So when we say enterprise solutions, you have different types of software available for manage different parts like customer relation management, human resource management, and so on. Right. And if you look at the web-based software application as a service, it's less depend on what is the computing power you have, because most of the time it will be cloud-based, which means you don't really have to worry about that part. Similar goes with the maintenance as well, right? The maintaining like the hardware part will be minimized. Now, when companies acquire software-based software as a service rather than a product they purchase, they can limit in-house involvement to minimize and have vendor install, configure, maintain. So if you use web-based software, but you are not going to have your own, then you don't have to really worry about that part, right? You can focus on the main functionality in the organization. Now, otherwise, what will happen? You have to worry about the hardware. You have to worry about keeping track of data and everything. But if the vendor can manage everything for us, so you need some additional layers we call middleware For example, one is to communicate with the existing software and also legacy systems. Right. Now, if you look at the web development, and there are different versions people talk about, web version 1, 2, and then people now talking about web version, even version 3. And here, I'm going to focus on web version 2.0 and cloud computing. That is the second generation of web. Now, in second generation of the web, we talk about people to collaborate, user generation content. Now, for example, the fuel, we have the software, the Helakuru, for example, to know that where the fuel is available, people actually collaborate each other, user content was generated, right? Interact. And also we have used a lot of social media networks to share information. So that is web 2, and that is what the current, right? And these are based on use applications, especially dynamic web pages, especially to modify exchange data. And interaction are there, for example, use of JavaScript, and a lot of JavaScript frames are there. In web software nowadays, you can have a lot of interactivities there. So things like we can talk about sharing information with wikis and blogs, and also like social network applications like Twitter, LinkedIn, and Facebook. Although we talk about web 2 a lot, I think some of the people, they started talking about web 3 as well. I'm not going to discuss in very detail, but now you can see in web 3 what is happening. Right. So when you talk about web version 2 with cloud computing, version 3, I will come with the next slide. The term cloud computing, we symbols that it indicates a network, or is it in the internet, and especially we use a browser and the network connectivity to work with computers, to work with the middleware, to work with our applications and the data. So overall, online software and data was supported by the supercomputer technology, and cloud computing would be an ultimate for software as a service, delivering service data users who would need only an internet connection and a browser. So you can see this is where we were heading, right? And that might be the, okay. So the next one is, I think I talk about the web version 1. In version 1 in 1990 to 2005, people talk about the basic web pages, HTML, electronic commerce, and Java and JavaScript. And with version 2, that means 2006 onwards, and I think up until 2016, because some people say that, okay, web 3 is already started. Some say that, okay, it will be future. But anyway, you can see that we are now, I think, transiting from web version 2 to 3. Currently, we are at the transition stages from web version 2 to 3. Now, in version 2, the main things we highlight is social media, user-generated content, mobile access, high-quality camera, video, and we talk about a lot of apps, right? And corporation monetizing our data, like people do use a lot of our data to get a margin and do marketing edge with the competitors, and high-speed communication and global internet access. Whereas if you look at what is our future, it will be semantic web, not just the social media. And we call, instead of apps, we call DApps, distributed apps, which means it's decentralized, not a centralized application that we talk about. And users monetize their data, not the companies or the organizations. And NFTs, VR, AR, and blockchains, all these buzzwords that we talk about these days will comes under this. And also like smart application, which have artificial intelligence and machine learning, right? So those are the our future, and people say that we have in the transition from web version 2 to version 3. Right. Okay. So having said that, let's look at outsourcing. Now, outsourcing is a common term used in development, especially when it comes to information system development. There was a time we outsource everything. That means we are not going to have in-house development. We outsource, we give some of our development work to outside. And this could be outside firm. Usually they provide it as a service for a fee. This could be temporary or maybe long time basis, right? So there are two popular outsourcing options that we are going to look at. That is application service providers, or in short we say ASP, and internet business services, in short we call IBS. So let's look at in briefly what these two. So application service providers is the firm, they deliver software application or they provide the access to the application. But for that, we have to pay some fee, right? So what they provide is not just a license. It'll give you the operating package, right? So usually they will provide, database, accounting packages. Usually those kind of software comes under this one, right? For example, the advantage you might get is, for example, if you take data management package, you don't have to design, develop, implement, or maintain any of these, right? So that's what we call application service providers. The second one is we call internet business services. That means you will get web-based supports for, order processing, billing, customer relation management. There are some software actually, built for this purpose, right? Because it has the online center support and the computing power will not be a critical factor compared to what you have already. And you can have access the system from anywhere you want using any device. So that is one of the advantages you will get if you use internet business services. And next is offshore outsourcing, or sometimes we call global outsourcing. That means use of IT development, support operation to other countries. Now, sometimes you can see, if you look at especially the software development companies, some companies are here in Sri Lanka and their mother company will be in US, Canada, Australia, and sometimes their development rotates, right? And a mother company usually outsource the projects to Sri Lankan company and so on, right? So this is actually increasing. The reason why is like sometimes developing a software in a developed country will be really higher, whereas they can done for a cheaper price if they come down to for example Sri Lanka or India. So that might be one of the reason why this is actually quite popular nowadays. And then we can talk about the in-house software development. Company can develop their own system, because like one of the problems, if you can see, is there are a lot of dependencies when you actually purchase a software from outside, right? So many prefer start from scratch and they have their own software developed in-house, right? But remember that when you are actually doing this in-house software development, you have to think about the total cost of ownership. It's not just the software that you are going to spend for creating the software. You have to think about, debugging as well as later on, right? How do you maintain software? So all these costs should be, considered, right? And then you can have other packages like Office that simply improve the productivity and efficiency in organization. Right, now if you look at the choices available, right, either you have to buy or we have to build, right? So when you say make a build, it will be usually in-house system or customized software. If you purchase, it will be a commercial software package. right? So for example, if the organization business function is totally different from all the others, then you can have to develop yourself because common ones are not available. But let's say if you're doing some common day-to-day, activities like in the others, like most of the time there could be, commercial software packages already available. Right. Now, if you compare the reasons why in-house, as I said earlier, when you say in-house, it's basically can satisfy unique business requirement. Because many of the time, let's say you have your own unique problem, then definitely you have to go for in-house development, right? But if you go for software packages, the price will be low. It will be lower cost. But then the business requirements are more general. The second point, we can minimize changes in the business procedures and policies, right? Because you are going to have your own software solution, so you don't have to really worry about whatever the existing procedures. But then again, if you purchase from outside as a software package, then what you need is you need less time to implement this. But remember, sometimes you have to make changes in the procedures and policies in the organization. Third one, meet constraint of existing system, because whatever the constraints can directly apply. And from the software package, we can say the reliability and performance benchmark is there. Then meets constraint of existing technological development. You can also like meet the constraints. And then when you have a software package, it requires less technical development staff. The next point, develop internal resource and capabilities. If you do, in-house development, always you develop the expertise within the organization. Whereas if you have like purchasing, which means you depend on somebody else, right? You depend on future upgrades provided by the vendor, but nothing else, because it's very specific. The last point is satisfy unique security requirements. So that is possible with when you have in-house development. And then here you have to get the input from other companies. Right. So let's look at the customization, customizing software packages. Now, when you look at the standard version of software product, that is standard version will not satisfy what is required by the organization. So what we have to do is we have to adapt the package to meet the needs. So to customize the software package, if you're purchasing a software, is you purchase the basic package and then you use vendor to customize it, right? Second one, you can negotiate with the software vendor to make enhancement to make your needs by paying charges. So that is also possible. Third one, you can purchase a package and then you can make your own modification. I think a lot of time nowadays we depend on open source software solutions, and then what you can do is, that means you don't have to spend money on open source software. You purchase it, but then for the purchasing it will be free, but then you customize it so that you can use it. So a lot of free and open source software available for you to look for this. Right. The next one, analyzing cost and benefits. Now, when you talk about the software development, there are a lot of costs involved, right? So sometimes you might think it's only the cost of, software, cost of, person who involved it. No, it's not like that. There are many others. So when you talk about total cost of ownership, there are some other types of cost involved. Now, for example, direct cost. That means when you're purchasing, you have to pay some cost. Then there will be indirect one. That means you need to support, ongoing support, maintenance, like something failed, then you have to support. So those comes under indirect expenses. So when you look at several alternatives, whether you are going to have your own in-house software development systems, or whether you are going to take a web service, right? So you have to look at all these different types of cost, and then only you are going to make a decision, right? So when you say look at some inexpensive initially, right, and sometimes when you look at the total cost, you will see that it will be the most costly choice. So we have to think about this as well. For example, when you look at the forecast, nearly 80% of the total cost occur after purchase of the hardware and software, right? So that you have to be very careful. Right, now we'll came to the second half of the 2 days talk. That means now that we discuss different alternatives we have to think about the financial, the aspect of this one as well. So financial aspect mean here is we can look at, time it takes to, pay back. Now, for example, when you're developing a system, initially you have to incur some cost. That means the developing time. Let's say you develop a software for 2 years, then during 2 years you are not getting any benefit. So benefit comes once you apply or once you deploy the software system, right? So that means you spend some amount of money and then you will get the actual benefit later on. So it will take some time. So payback analysis is we can determine how long it will take for a system to pay itself through the cost and with the benefits. So we are basically analyzing what are the costs and what are the benefits. And then another one is to return on investment. That means we can look at the project total return with its total cost. So basically you look at the basically total cost, the project return and project total cost. And the final one, actually, we will look at net present value. That means we'll consider the time effect, because some of the benefits comes later on. It will be not the same as the benefit you are getting right now, right? So for example, let me ask a question. So do you like to have 10,000 today, or let's say 15,000 after 3 months? If you ask something like this, so how do you make the decision? Right. Let me say this, whether you would like to have 10,000 today and 11,000 after 3 months time. So you see my point here. So that means you have to look at, because the amount that you are getting is not in the same time. One amount you are getting now, another amount you are getting after 3 months time. So it's not the same, right? So that we have to match, and that we will do under net present value, right? So that means we consider the time it takes to get the benefit, and we are going to make it for the current benefit and see. Okay, right. Okay, now before we calculate the cost and benefits, here are the list of things you have to check. First of all, you look at each development strategy. As we discussed earlier, it could be a traditional development, it could be some web-based development, and so on. And then the second point, you identify all the cost and benefits. Cost means initially you have to spend some time, then after you implement, then you are going to get some benefit, meaning that you have reduced the costs, right? And then look at for the future growth, and also look at for the scalability. Fourth point, you have to include support cost, hardware, software, because things are changing, right? That means you have to change all these. And then if you have various licensing options, that sometimes they say, okay, this license only for personal license. Sometimes we say school level license, and so on. We have different licensing options. And then we have to look for these. So you need to analyze various software licensing options. and then apply the financial analysis to each alternative, and then you look for the results and prepare a report. So let's look at some of these things with an example. Right. But before we are going to talk about all these three methods, let's look at the software acquisition process, right? The process is, there are serious steps. First one, you evaluate the system requirements. So usually we talk about technical requirements, we have non-technical and so on. So we evaluate what are the exact requirements. Then consider the network and web related issues, and then identify potential software vendors or outside outsourcing options. You can think about what you are considering. And then you evaluate the alternatives. For that, we will actually use 3 tools today. And then we perform cost benefit analysis. Then we prepare recommendation. And then only depend on the recommendation only, we are going to implement the solution. Right. Okay, during software acquisition, company can use a request for proposal, RFP, or request for quotation. And RFP invites vendors to respond to a list of system requirements and features. RFQ seeks bids for a specific product or service. So for example, most of the time actually in university, when we want to, let's say, purchase something, some software solution for, let's say, account, we go with the features that we need, and then we'll request for quotation. So that's how usually we will have. And sometimes when we are not sure about our requirement, now remember some time back we had a requirement to have CCTV system, and we were not sure where to put CCTV cameras. So then what we did, we request for proposals, and then we evaluate those proposals, because we don't know the numbers, we are not the expert. So as a university, what we did, actually we request for proposals. We request the proposals to cover the security of entire university, and then we evaluate the proposals. So depend on our requirement, we can either go for a request for proposal or request for quotation. Right, now transition to the system design. The system requirement document is the deliverable or the end product of the system analysis. So what it has is the system requirements, the constraints, and also it may contain what are the recommendation for the best solution, and also the cost and time estimate, because this is the document that we are going to base on, right? So this will be the basis for the management presentation, and then firm can decide whether to develop in-house, whether to modify current system, or whether to purchase a software package, and so on, right? So that is once you actually depend on this. Okay, now let's move on to the cost calculation. So let's look at first what are the different types of costs. Cost can be classified as a tangible and intangible, or direct or indirect, fixed or variable, or development or operational. So let's look at in detail. Now, when you talk about tangible, that means when you specify specific dollar value, that means when you say salary, it's fixed. Hardware, you have a particular amount. Software, that particular amount. And intangible means you cannot, some things that you cannot calculate. Now, for example, customer dissatisfaction. So customers are not happy with the service or the product that we deliver. So how do you measure this? That it's not direct, you cannot put like how many dollars and so on. It's very difficult. And sometimes the employees are not motivated enough. So how do you do this? Like again, how do you assign a cost for this? Right? And then reduce information availability, you make the decision. Again, you cannot put exact dollar amount or the value for these, and therefore they are categorized as intangible costs. The next one is a direct cost and indirect cost. Right? Direct cost means the cost associated with the development of the system. Right? So for example, salaries of the project members, purchasing hardware, software, and so on. Indirect cost is other things, right? So sometimes some of the cost which not directly applicable to the development of the system. For example, salaries of network administrators, they are not comes directly, but indirectly. Copy of the machine rentals, insurance expenses, so they can be considered as indirect. Although they are not direct, you have to indirectly consider them as well. Next, fixed costs and variable costs. Fixed, relatively constant, right? So salaries, hardware rental, they are fixed. Then we have variable costs, right? For example, paper, supplies, telephone charges, like they are called variable costs. Final one, development and operational. Development means like you're going to develop the system. It happens only once. So the cost will be the salaries of the people who develop the system, software purchases, initial user training and so on. Then we have operational cost. Right? Once you have developed the system, to run the system, you have to spend some time. Right? System maintenance, the training, annual software license fees, communication expenses comes under operational costs. Okay, now that we have looked at all these, let's look at the cost to multiple categories. Right? Some cost, for example, it applies to more than one or more category of expenses. Right? For example, if you take overtime, right, system analysis phase would be classified as a development, variable, and direct. Or if you take monthly fee, right, it could be operational, fixed, or indirect. So you can see like some of these costs can be classified into multiple categories. Now, the next thing is the benefits. Again, benefits are two parts, tangible, intangible. That means or fixed or variable or direct or indirect, right? And it can be classified based on the nature of the benefit as positive benefit versus cost avoidance benefits. So positive and cost avoidance benefits. Positive benefit, that means that can increase the revenues, improve the services, or it could contribute to the organization, right? So for example, improved information availability. Once you develop a system, deploy, and it will improve the software availability, right? Greater flexibility, faster service to customers, higher employee morale, and better inventory management. Now, the next one is called cost avoidance benefits. Then there are some expenses necessary when new system were not installed. Handling the work with current staff instead of hiring additional people, not having to replace existing hardware solution, and avoiding problem that otherwise would be faced with the current system. So these are called cost avoidance benefits. Okay, so let's first start with the cost benefit analysis. In here, what we do, we compare the costs with benefits, right? So you will look at the system development life cycle, you determine the feasibility of the system project, and then you can compare the alternatives. So if you look at many cost benefit analysis, there are many, and what we are going to look at today is payback analysis, return on investment, and present value analysis. So let's start payback analysis. Now, payback means whenever you are going to develop a computer system, it will take some time to develop and to finish, right? So during that, right, we have to determine what will be the initial development cost, and then annual benefits, annual operating costs, and then you can find the payback period by comparing total development and operating costs. Right. Let's look at a graphic. Now, in X direction, I have the time axis. The Y direction, we have cost in code. So when you are developing a system, so the cost will be higher, isn't it? You have to spend a lot of money. And towards the end of the period, you can see it's, reduce the cost. And then here, system operation, maybe using another. So you can see there's a decline here, and then you have a stable, and after time it is keep on increasing. So this is the traditionally the way how it look like. Right. Okay, now the benefits, this is costs. The cost will be initially higher, and after some time, then it will be flat, and then increase the cost. Then benefits, initially during the system development, there's no benefit, then keep on increasing the benefits. And when you want to define what do you mean by payback period, and when you look at area under the curve for the cost and benefits, when they meet, when they are the same, right, we call it payback period. So usually what you see in this dash line is, so area under this curve, this part, plus area under curve, these are the same, and this is known as payback period. So what you need to calculate is time it takes for accumulated benefits on information system to equal the accumulated cost of developing an operating system. So you can see in the previous one, dash line indicate this one. Okay. Right. Now, here is an application. So you can see there are two projects now we are going to consider. Right. In the two projects, what we are going to look at is we will have the year cost, accumulative cost, benefits, and cumulative benefits. So there are, 0 to 6, the year value, the cost that you spend on project A in year 0, initially 60,000, then 17,000, 18,000, and so on. Then you have cumulative costs here and the benefits. So benefit means like the advantage you get by implementing the system. So that will be 3,000, 20,000, and so on, right? And then this is cumulative. So you can see if you look at the starting value of 60,000 goes up to 181,000, here 3,000 to 230. So you can see at some point the values are the same. That means the cost and benefit will be the same. So at that point we can say, right? And similarly, you can look at the same figures for project B as well. Right. So let's perform payback analysis by looking at project A and project B. Yes. Shall we start then? So how do you look at payback period? Right. So we have to look when the amount that you have spent on this, that means the cost will be when it going to same here. So that's exactly what we are going to check. Right. So what do you think about the cost and benefits? Let's look at project A. When do you think when the cumulative cost and benefit are the same? In which year?
Yes,
Yeah. Can you tell me like how do you match? Now let's look at project A. Let's look at at the end of the first year. The cost will be 60,000 and cumulative is 60,000. The benefit is 3,000. Now what we talk about the payback analysis means we want to find out when it meets the cost and benefits are equal to each other. So that is known as payback period. So in project A, in which year we will have this meeting the cumulative cost together with the cumulative benefits?
Yeah, fall like near the
For example, if you look at after the year one, the cost will be 77,000, but the cumulative benefits again 31,000. It's not matching, right? So benefits should should be more than the cost, right? So if you look at the after year 4, you can see here the cumulative cost will be 135,000. The benefits are 130,000. It still is missing. But somewhere in year 5, you can see, right? Somewhere in year 5, you can see this is exceeding, right? So we can say that payback period is between 4 and 5, isn't it? It's not 5. It's more than 4, but less than 5. You got my point? So those who have understood, can you raise your hands? So what we say here is the payback analysis. In payback analysis, what we do is we look at what are the costs are, and then we will look at what are the benefits are. And at some point, the total cost, the cumulative cost will be same as cumulative benefits. And this is known as payback period. I will repeat. So in system development, like happens earlier, you spend a lot of money and after some it is actually degrading. In benefits, initially no benefit and it will keep on increasing. So in some point when you have these, whatever the area under the curve, right? So let me have red color to mark this one. Let's say this part. If this part is same as this part, area under the curve, we can say that this is the payback period, right? So the area under the curve. Now, by giving you 2 tables, by looking at each year, you can say where will be the payback period. So exact time, you have to do some calculation for that, but roughly you can see when you meet the cost with the benefits. Okay, so let's move to the second one. Can you tell me what is the payback period for the second one? Yes. What is the payback period for project B?
5th and 6th year.
Yes, again, you can. you can look for the years. Like for example, cumulative cost is 80,000, no benefits, 126,000, 145, 32,000, 167, 86,000, 191, 158,000. Okay, somewhere here, right? It's exceeding, right? So again, between 4 and 5. You can actually, have a Excel diagram for this one, right? So for example, can you put this value in Excel sheet? And we can see when the two meets. Right. So I will take a simple Excel sheet. I will do this for project A. You can do this for project B. So what I'm going to do, I'm going to have cumulative costs and benefits. So I'm going to put cumulative costs and benefits, right? So we can have cumulative costs and then we can have cumulative benefits. Right? So what you see here is 60,000, 77,000, 95,500, 114,700, then 135,700, 157,700, and then 181,000. If you need year number, you can have that one as well. For example, I can put years, right? This is the first 0, 1, 2, 3, 4, 5, 6. And the benefits also I can put. So I will put some benefits here as well. So the benefits are, we have 3,000, then 31,000, then 62,000, then 96,000, 132,000, 171,000, 213,000. Right? This is what I have. Right? Now I can have a graph. Let me insert and maybe I can have a line graph. Okay, so here is my line graph. Yes. So this is my line graph. And this is for project A, right? This is project A. This is payback analysis. And then you can see where these two meets. I have to change the axis though. So I will change the select data. And then Series 1, I'm going to edit, that is cumulative cost. Series 2, edit, that is cumulative benefits. And here I'm going to have years. Right. Okay. Slightly modify the layout. Okay, maybe which one is the best? Okay, I think this is fine. That is the costs. So you can see the two intersects each other somewhere down here, right? Okay, so can you share the same diagram for project B? Can you do the same? Right, I will send you this as a graphic you to work on in the WhatsApp group. So I have put the document. Shared in the WhatsApp so that you can work on this. You can do the same for project B as well. Let's do the second one as well. I will share my one later on. So I will do the B as well. So similarly, we can write down the values for project B as well. And the cumulative costs are, we have 8,000, then 120,000, 145,000, 167,000, 191,000, then 217,500, then 247,500. And similarly, cumulative benefits, let me change my sharing. Right, cumulative benefits. So you don't have any benefit for the first year, then we have 6,000. Then we have 26,000, 54,000. Sorry, it should be 32,000. And then 86,000. 156,000. 238,000. And finally 330,000. Yes. So the steps are, I'm going to select the data area first, go to insert, then I will take line plot. Yeah, here also I think chart type. Yeah, first one. Here also chart type. Yeah, it should be first one. Okay. Right. So this is for the project P. And here also we can change the select data. So the series 1, edit cumulative costs, edit cumulative benefits, and this is the number of years. Okay. Right. Let me use the same format. Right. So this is project B. So this one takes about 4 years, little more than 4 years, but this is almost 5 years, right? So by looking at the payback analysis, by looking at this, we can say, okay, maybe project A is the best one. Right. So I got from answer from Chamila. Let me share Chamila's one. Yes, here is the Chamila's one shared with me. Thanks, Chamila. Exactly, you can see here. One thing to change, Chamila, you should have changed the values of x-axis. The values that we have used from 0 to 6. In year 1, it goes from 1 to 7. So you can actually change that one. Other than that, that's fine. So this is exactly what I need. Right. Pradeepa also shared me. Yes. Pradeepa one also, like you can change the labeling. So those who have difficulty changing the labeling, this is how you are going to do. So once you have selected this, you go to home, select data. So you select this. You go to chart design, select data, and then change the values here. Click edit, select cumulative costs, click edit cumulative benefits, and click edit here, select from 0 to 6, and then you should click OK. Okay, Sivakumar also send me an email. That's fine. Okay, I think those who could not, they can try later on by going through this. So let's move to the next analysis. So the next analysis actually called return on investment analysis. Now, this one actually based on the total benefits and the total costs, right? So this is defined as total benefits minus total costs divided by total costs, right? Total cost minus total benefits minus total cost divided by total costs. Okay, you can check that how long it will take. Return of investment, ROI. So usually this is based on, it says 5 to 7 years. So let's try to, check this total benefits minus total cost and divide by total cost. Right. So the ROI for project A, let's calculate ROI for project A. Right. So it should get total cost and benefits. Yes, total cost and the benefits. We have to look at it.
230,000
Yes, we have 213,000
minus 100
minus,
81,000
yes, 181,000
divided by
divided by,
181,000.
yes, 181,000. So this is called ROI, return on investment. Yes, when you simplify,
17.7.
how much you got?
70.7.
Yes, as a percentage. So this is the ROI for project A. Yes, can you calculate for ROI for project B? So the formula is ROI is total benefits minus total cost divided by total cost. That's how it should go. Yes, can you tell me like what is the ROI for project B?
33 point.
Yes, 30.
3.3.
So what we need to do here as well,
330,000.
yes, we have 330,000 minus 247,500 divide by 247,500, right?
No.
Yes, now divide it.
It is 25%.
Should be 33.3. I don't know. Can you check?
33.33.
Yeah. So it should be 33.3%. Yes, divide and see. Right. So return of investment, when you check it, according to what we have got for the project A, it will be about like 17%. And project B, it will be about 33%. Okay. Yeah, Prasanga, Shifani, yes, both agree. Right? So this is what we are getting for the return of investment analysis. Right? For the project 1A, we are getting 17.7. And for project B, we are getting 33.3.
And doctor?
Yeah.
Yeah, I have a small question that that payback period, are there any that good value that is this range of value is a good payback period time or any like that?
Yeah, I mean, like if you look at the first one, the project A, the payback period is around like little more than 4 years. You can actually find the exact point. And the second one, project B, it will actually almost 5 years, which means you can say if you base on payback period, because the payback period tells you how fast you are going to, get to the cost and benefit. Because you spend a lot of money and then how fast you reach that amount is the payback period. And then you can say, okay, project A is better than project B. Now here it's a slightly different. You are looking at the total costs. You look at total cost and benefit and you see that return of investment is 17.7 for project A. Return of investment for project B is 33.3. So, different analysis, financial tools actually look, different things. Now in this one, you can say that, okay, you can think that, okay, project B is the best, but usually when you have a return on investment, you have a minimum value. Now, for example, if you say the minimum return of investment is 15%, if that is our expectation, now you can see both A and B exceeds this amount, which is both A and B is good. But if you want to make a ranking, then you can say, okay, project B is better than project A. So are you on agreement with me? Are you comfortable with the two techniques that we have discussed so far?
Yes, doctor, we agree with.
Yeah. So you can have a look at in the text one as well. Right. Okay. So, but there are some critiques on this return of investment. Now, a return of investment, you see, we look at both total cost and total benefits, right? But the problem is the amounts that you get the return, the date, the time is varying. You see the point. The return that you are getting depends on different times. So this might not same as the benefit that you are going when you're comparing with the other project. So we can consider this one. The return of investment technique ignores this timing. So that means, remember I told you, like getting 100 rupees today and getting 100 rupees next year, getting 100 rupees in another 2 years time, it will not be the same. But return on investment looks at that point. So you just look at the amount, not the timings. So the timing is very, very important, right? So timing and the amounts is very, very important. So the time effect we need to consider. So one of the issue, the criticizing for return of investment is it will just ignore this timing effect. So the next one, we are going to look at this, the timing effect, right? So the last one we call present value analysis is actually what you are going to get by the future. You are going to convert the present value and you are going to perform the analysis, right? So the future dollar amount, you are going to calculate what will be the present value. So let's say in this one, for example, we look at dollars because it's actually example from the book. So in here, so depend on, the rates that we actually expected. So in a 6%, usually we will talk about some interest rate. And if you have a 6% rate for 1 year, right? This is the amount that you will have for a $1. So how do you calculate this one? So this is already given. Usually books will be given. So you need to know how to read that one. Now, for example, what it means, if you to have a $1 today for a year time with a 6% of interest rate, what you need to have is 0.943. You got my point? How do you get this? So how do you get this? Right? To get a $1 today, this is the amount that you need, right? That is 0.946. If it is 8%, what you need is 0.926. If it is 14%, this is what you need, like 8.77. Now, you know that interest rate nowadays, it's about 14%, if I remember correctly, which means if you, what you need in to have $1 today, right? Yeah, this is the amount, right? When you have $1. So portion of present value table showing adjustment factors for the various time periods of the discount rate. Values are table are calculated using the formula shown in the text. Right, that I will discuss. Right. So, but right now, what you need to learn is how to, look at the future value for today's net present value, right? So for example, to have a $1, right? The 10 years time that it should have is 0.558. So you can cumulatively, you can calculate what will happen. So now let's look at some example. Now, for example, let's say we need to find out net present value for $1, 12% for 5 years, right? Present value of $1 at 12% for 5 years, right? So that will be, right? If you look at the table, you go back to the table. Right? So now you go back to the table. So we have 5 years, that is the period. The value is 12%. From here, we'll get 0.567, right? So that is the net present value for $1 for 5 years with 12%. Okay, now if you're asked to find the value of 3,000 then for 12% for 5 years, right? For $1, we know it's 0.567, and you multiply with 3,000, that will be 1,701. 1,701. So that you made the correction, right? What you have to have today. So you have to have 1,701 to get 3,000 by 5 years time with the rate of 12%. I hope you got my point now. And you have to have 0.567 today to get $1 for 5 years with a 12%. That is the value for today. Right. Now, let's look at how we are going to perform the calculation. Now, this is the correction. Whatever the future amounts, we are going to, make it to present value, and then we are going to do the analysis. So what we need to do is we have to time adjust the cost and benefit figures. So you have to multiply both cost and benefits with the proper factor, and summing will give you time adjusted costs. So net present value, that means the total present value of the benefit minus total present value of the cost, will be the net present value. So if you have a positive value, then you can say it's economical feasible, right? And you can use it to compare rank. And then if we have equal values, highest NPV is the best investment. So that's how we are going to look at it. Now let's perform NPV analysis, net present value analysis for project A and project B. So I will start with project A, and then you can do this for project B. That's okay, no? So now what I'm going to do is I'm going to prepare a table, right? So I will take a whiteboard for this to understand. First of all, I will share this table as well, so that you have everything you need for the calculation. Right? That table you need to understand the calculation. So let me right now I have shared this in the chat. Yeah, did you get the table?
Yes, sir.
Yeah, okay. Right, now let's perform the calculation. Now for that, I will, use whiteboard. So let me stop sharing. And then I'm going to use whiteboard to do the analysis. Right. Now for each benefit for the years, I'm going to look at the benefit and costs. And then I'm going to look at the present value. Right? Then when you are subtracting the cost and the benefits, right? And if it is a positive value, we know that it's economically feasible. Okay, let me share my screen. Can you see the whiteboard?
Yes, doctor.
Yeah. So what I'm going to do, I'm going to have years. Let's say I'm going to say year 0, and then year 1, year 2, year 3, year 4, year 5, year 6, and then I'm going to have total. Right. So these are the labels that I'm going to have. And then I will have benefits. Right. Then I'm going to list present value factors, present value factor. I'm going to assume that it's 12%. In the exam, normally it will be given. Right. And then we will look at present value. Right. Right. I think now we can start. The first of all, we'll have the benefits. The first year, it's 3,000. So $1 will be $1 within the first year. So no change. So I can put 1 here. And net present value also will be 3,000. Are you in agreement? You can look at the table. Right? Because 0 means the same year, there's no change, same value. right? What about the year 2 benefit? Year 1, it's 28,000, right? It's 28,000. That is year 1. What is the present value factor? If it is 12%, $1 from 1 year from nowadays, what is the value now?
0.8.
893, right?
Yeah, 0.89.
Yeah, we have to say 0.893. So that means $1 after 1 year will be worth today, that is 0.893. So 28,000, if you multiply by 0.893, what is the value you are getting? So that is the net present value for 28,000.
25,004.
Yes, 25,004, right? If you multiply these two, the present value, it's 28,000, the benefit that you are going to get after 1 year. But if you calculate for the today's value, it will be 25,004. Yes, exactly. Now I think you will see my point. Now, the second year, the benefit that we will expect, or benefit according to this one, is 31,000. Right? And what is the present value factor for 12%? Refer the table.
0.79.
Yes, if you look at, so that is 0.797, right? So that means to get a $1 from 2 years time, right? The value what you have to have right now is 0.797. $1 after 2 years will be worth 0.797 today. So when you multiply this with 31,000, you are getting 24,707, right? So this is the value that you are getting. So you are getting the benefit that we expect at the end of 2 years, we are getting 31,000, but when you convert to the present value, it will be 24,707. Right. Can you do it for the year 3 and can you share me your answers? For the year 3, the benefits are 34,000. Okay, once you do the till year 6, now find out the total value, right? So what is the total value here? You add everything together. Yes, can you tell me what is the value? So I'm not going to fill the value. So what is the value you are getting here for the total? Can you share the answer? So once you calculate all the present value for year 0 to year 6, then you can add everything together to calculate the total, the benefits in the present value. Okay, check whether the total benefit is whether it's equal to 143,222. Check this. I will give you the values, by the way. Right. So let me put up the values. 34,000 for year 3. Then we have 36,000. Then we have 39,000. Then we have 42,000. So these are the values we had for year 4 and year 5 and year 6. Right. Then present value factor for year 4 would be 0.636. And then 0.567. Then 0.507. Right. So these are the present value factors for a 12%. Right. So once you multiply these two, we are getting the actual value in the present value. Right, 36,000 to get by 4 years. What is the value today? Right, that's the question that we are raising. So when you multiply 0.636, right, we should be getting 22,896. Yeah. So that should be the answer. And similarly, when you multiply 39,000, right, we should be getting, what is the value?
22,130.
Yeah, 22,130. And for year 6,
21,294.
294. Altogether, when you add everything together, you should be getting 143,222, right? That is the total benefit for 6 years. Calculate to the present value by using. Then similar we have to do for cost as well. The costs are for the first year, it's 60,000. Yes. Then 40,000. Sorry, 40,000. 25,000. Let me know if I'm making a mistake. Then 22,000. 24,000. 26,500. Is it 30,000? Last one?
Yes. So first one should be 80,000.
Yeah, it should be 80,000. Yes, correct. So this should be 80,000. All the other values are okay, right? Right. Then same values as the previous, so I can copy paste this one. The same values apply here because it will be the same. Right. Can you tell me what are the values for year 1? 40,000 will be reduced to
35,700.
720, right? Okay, good. 25,000. Can somebody tell me the value for year 2 for the costs? 25,000 will be reduced to
19.
19,000.
925.
925. Good. For year 3, yes, 22,000 multiplied by 0.712.
15,664.
15,664. Then 24,000 into 0.636.
15,264.
Yes, 210. Is it 15,264? Then 26,500 into 0.567. 15,026. Then 30,000 into 0.507. That is 15,210. And when you add the total, no, I think I made a mistake.
So, excuse me, the benefit we considered for project A, right? The costs
Yeah,
we have,
I think I made a mistake there.
costs we took for the project B values.
Yeah, so this is wrong, right? It should be 60,000. This is cost should be, yeah. I think I made a mistake with that one earlier. Confuses. So this should be 17,000, right? It should be project A. And this should be, sorry guys, 18,500. I think I mixed with the project B. That is what has happened. The cost for project A. Then this should be 19,200. 21,000. 22,000. Then 23,300, right? Okay, so that was a mistake. Remember, we are discussing project A yet. So what we discuss is project A. So we have to consider both cost and benefit for project A. So the mistake I have changed from here. Right. Yes. Now that we have, is it 15,181?
Yes, doctor.
Yes.
Yeah, sorry about that. 15,181.
Then 14,670.5.5.
May I put 15? Then 13,670.
Yes. Yes, doctor.
Then 21,000 into 0.636. Is it 13,356?
Yes.
Then 12,474. Final one 11,830. So sorry about my confusion with the previous one. Right. When you add it up, what is the total cost present value? When you add it up? So when you multiply 18,500, I'm just checking. My calculations. $18,500. You multiply by 0.797. It should be 14,745, right? Not 15. So what is the total that you get from here for the costs? Check the answers. Some of you, my answers are also not correct. Yes, it's 141, 239. Good. I think majority of you got the correct answer. Yeah, so it should be 141,238, right? Okay. Now to find the net present value, that is the last one, net present value. You subtract these two, and if it is a positive value, we say it's a financial feasible. So when you subtract, you will get 1,983. Yes, 1,983 for project A. So that is how we calculate the net present value. Similarly, check for project B. I'm not going to spend time on that, but let me give you the answer for project B. So project B, you should be getting net present value 5,377. Just check for project B. So project B, you should be getting net present value of 5,377. Yeah, make a note of this and try this at home. Right. The idea is very simple, right? Now, instead of ROI, return of investment that we have calculated in the previous setting, we look at only the total cost and benefits. But in net present value, since we are getting in different times, we will consider this timing as well. So we define something called present value factor, and we will have some interest rate, let's say 12% in this example. Say that, okay, what if to $1 to get from another 2 years time, what should we have right now, that value? So with the 12%, we know with the same year, no change, but after 1 year time, right? Present value to get $1 after 1 year, we have to have 0.893. After 2 years to have $1, we have to have 0.797 and so on. So which now you see the total cost benefits are adjusted. And once you adjust the total cost and benefit, and when you subtract and when you find net present value, if the value was positive, we say that this project is feasible. Right? That means the benefits are higher than the costs. And we are discussing the change of time as well. Right. So let's back to the slides. I think that's all what I have for today. What you need to remember about the net present value is few things. Why we use net present value analysis is provide solution for ROI, return of investment, because it will not consider the timings. And it's also compared to payback analysis, net present value or present value analysis consider all the cost and benefits. The payback usually to check when it reaches the cost and benefits. And at the same time, present value analysis consider the timing of cost and benefits and the time value of money, which is very important, right? So although we discussed this as 3 different financial analysis tools, depend on the companies, they may use all the 3 methods to get more input, because 3 methods will capture 3 different things, right? So when they want to make a decision, they may use all the 3 methods, right? So with that, I'm going to finish today's discussion, and we are not going to have any group work today because of the time constraint, but I will send you some question on net present value. There will be another question in the handout, and you are supposed to submit individually the answer for this question. So there will be a 1 net present value analysis exercise with the handout. So I will share the handout, and then before next week, you are supposed to finish that exercise and submit the answer. So that will be individual. Okay, any questions on what we have discussed today? Right, just to summarize then, if you have no questions, what we did, we look at different development strategies, and we discussed the traditional way of software development as well as what is available nowadays, like cloud-based system, and then as a software as a service, and also like we also briefly look at what might happen in a web 3.0. And then we discuss different costs involved in software development, and we look at 3 financial analysis tools to evaluate different projects, right? So that means like when you have different strategies, we should be able to identify which one works best, right? Which one is the best for the financial, depend on cost and benefit. So that's what we discussed today. Right, having said that, we'll finish discussion for today's one. So next week we will look at more on design, user interfaces, data design. So that part comes next. And until then, we'll break for today. So hope to see you guys on next week. Thanks then.
Thank you, Doctor.